Welcome to another video of Web3 Security. Today, we are uncovering the mechanics of front running, a sneaky blockchain exploit that can lead to massive losses, especially in DeFi. Attackers use blockchain transparency to exploit pending transactions. I'll explain how this works, show you a vulnerable contract, and demonstrate an exploit using Foundry. Let's dive in. So, what is front running? Front running occurs when an attacker observes pending transactions in a mempool and strategically places their own transaction with higher gas fees. This ensures their transaction is processed first, allowing them to gain an unfair advantage. Let's look at an example. Here you can see that Alice has placed a transaction called transaction 1. It goes to the mempool and it is visible to the hackers. So a hacker places one transaction, that is transaction 2, with higher gas fees. You can see that from the dollar sign, and that goes to the mempool as well. So the miner picks up the transaction with highest gas fees and processes it first. So you can see in this table that transaction 2 with the highest gas fees is processed first, then transaction 1, and the other transactions after that. Let's talk about a real world example of front running. So a user submits a large token swap unaware the transaction is visible in the mempool. An attacker observes this transaction and places their own trade with a higher gas fees. The attacker's trade executes first, profiting from the price changes caused by victim's transaction. Let's code a POC. The link of the code you will find in the description if you want to run the test yourself. So here, as you can see that I have written two Solidity files. First one is naive AMM. It's a simplified AMM which allows us to swap Ethereum for a token or swap token for Ethereum. Now we go to the attacker file. Attacker file has a function called frontrun buy tokens that we are going to use in our tests. Now let's jump to the test. So in this test, what we are going to do is we are going to do the setup first. We are going to deploy the AMM with 10,000 tokens and 10 Ethereum initially. So then we are going to deploy the attacker contract. The attacker will have 5 Ethereum. We will give the victim 20 Ethereum to do a large swap. We are in this code, we are just adding labels to all the addresses for ease of our understanding. Now this is the test. In this test, what we are going to do is checking the initial liquidity of the AMM, like how many tokens it has and how many Ethereum it has. Now we see that the victim wants to swap 5 Ethereum for some tokens. Here we will check how many tokens he should get if he swaps 5 Ethereum. Then after that we will see a front running attack from the attacker, and at the end we will check how much tokens the victim was able to get. So this step logs the total Ethereum and total reserves of the AMM. Let's run the test case. So here you can see the test case has passed and the initial results was 10,000 tokens and 10 Ethereum. The victim should have got 3,333 tokens if there was no front running attack. The attacker puts a transaction of 2 Ethereum and gets some tokens out of the reserve first because he saw a big transaction was going to happen. Now when the victim swaps 5 Ethereum for tokens, he gets only, as you can see, victim's final token balance is 2451 instead of 3,333. So the victim got less number of tokens and attacker got more number of tokens. And when the attacker will swap the tokens for Ethereum back, he will get more money. So how can you prevent front running in your contracts? Here are some strategies. First one is implement slippage protection. Set slippage limits to failed transactions if execution price deviates too much. Second is commit reveal schemes. Use a two-step process where users commit to an action first, then reveal details later, preventing attackers from observing transaction details. Third is batch transactions. That is, bundle multiple transactions together to make it harder for attackers to single out specific trades. And fourth one, the most important one, is private transaction. Use flashbots or similar tools to hide sensitive transactions from public mempools. If you found this video helpful, Please like, share, and subscribe for more Web3 security tutorials. Thanks for watching.